Imagine you are drowning in logs, errors, warnings, debug messages. It is a nightmare. But what if I told you there's a simple, lightweight, and a powerful tool that can centralize all your logs seamlessly? Awesome, right? Meet Fluentd. In this video, you will learn the basics, its architecture, how to install Fluentd, and finally a hands-on demo. So stay with me till the end of this video because this will make your DevOps life so much easier. Without further ado, let's get started. Fluentd is an open source data collector that helps to unify logs from multiple data sources into a centralized repository. Think of it as a traffic cop directing the logs to the right destination. Imagine running a cloud app with hundreds and thousands of microservices. Each service spits logs, system logs, error logs, access logs, performance metrics. Without Fluentd, it's a chaos. But with it, all logs are structured, filtered, and sent to the right destination. Now let's talk about the reason why Fluentd is the best logging solution for the modern applications. Fluentd tries to structure the log data as JSON. This allows Fluentd to handle the log data seamlessly in its workflow across multiple sources and multiple destinations. Fluentd is a pluggable architecture and the Fluentd system can be extended by adding new plugins. It integrates with over 500 plus tools, whether you use AWS, Azure, Kafka, Nagios, Splunk, it's got a plugin for it. Fluentd is lightweight, designed for speed and efficiency. Fluentd is built on C and Ruby, requires very little system resource. Fluentd does not lose the log data. With its buffering system and auto retry mechanism, the log data is safe and reliable, even during failures. Fluentd follows a pipeline based architecture that collects, processes, and routes the log data in a structured way. Fluentd pipeline comprises of five major components: the input, the parsing, buffering, filtering, and output. Each of these components are wired together in our Fluentd configuration file. Let us review each of the components now. The input plugin collects the logs from the application logs, access logs, sys logs, TCP stream, database logs, or even a Kubernetes cluster. The source section of the Fluentd configuration file captures this configuration details. Parser plugin parses the raw log files into a structured format like JSON, CSV, or regex-based formats for better analysis. The, the parser configuration details are captured within the source section of the Fluentd configuration. Filter plugins allow you to modify, transform, or enrich the log data before sending them to the output. The configuration data for this plugin is captured within the filter section of the Fluentd configuration file. Fluentd uses an optional buffer plugin to store the logs temporarily before sending them to the output. The reasons mainly is around reliability. The buffer plugin configuration goes inside the buffer section of the Fluentd configuration file. Output plugin defines where Fluentd is going to send the process logs. It could be Elasticsearch, Kafka, Nagios, Splunk, you name it. The output configuration data is stored within the match section of the Fluentd configuration file. Let's recap whatever we have learned so far by connecting all the dots together in the Fluentd pipeline. We have the Fluentd configuration file which captures the configuration information for the input plugin, the parser plugin, the filter plugin, the output plugin, and the buffer plugin. The input plugin is going to collect the logs from our application. The raw logs that are collected will be picked up by the parser plugin and it is going to convert that into a JSON structure, for example. That JSON structure will go through a filtering process by the filter plugin. It's going to transform, modify, enrich the log data accordingly. The processed log information then will get buffered through the buffer plugin. Finally, the output plugin is going to push these processed logs to the destination. In our case, it's going to be Elasticsearch. This is what we are going to demonstrate in this video. It's now time for action. As a first step, we'll be installing the Fluentd. Then we are going to run our Elasticsearch and Kibana as containers. Then we are going to run our application as a container, which will be generating the logs. Then as a final step, we will be configuring our Fluentd to push the application logs to the Elasticsearch, and finally we will review those logs through the Kibana dashboard. I am going to install Fluentd on my Ubuntu server. As a first step, let us now update the package list. Awesome, it is done. Now let's head down to the Fluentd documentation, and I need to install Fluentd package 5 on my Ubuntu Jammy server, and this command is going to download and install the Fluentd on my Ubuntu server. I will provide the link to this documentation in the video description. Let us now install the Fluentd now. Awesome. Now the Fluentd is installed. Let us check the Fluentd binaries. It is there. Let's now check the whether the Fluentd service is up and running. It is active. For this demo, I am going to stop the Fluentd service and we are going to run Fluentd as a program in debug mode. Let's stop the Fluentd service now. So currently it is not active. The Fluentd setup is now complete. Next, we need to create our Elasticsearch and Kibana containers. I have created a Docker Compose file. Let us quickly review that Docker Compose file and let's create the containers. This is going to spin up an Elasticsearch container and a Kibana container. It's using the images which is mentioned in the Docker Compose file. I will have this uploaded to a shared location and will provide this in the video description. We're going to use the Docker Compose command to start these containers. So now we have our Elasticsearch and Kibana container started. Let us check that using the Docker ps command. We are seeing the two containers up and running. We have completed step 2 now. The next step is we need to create our application container. We are going to create our application container using Docker Compose, and we need a Docker Compose YAML file, which is what you are seeing on my screen. Our application container will be based out of a busybox Docker image, and we want our container to be up and running always, which means we need to have some script in place which gets executed continuously. And this while loop the infinite while loop is the one that will keep the container up and running always. It is going to create a JSON string. It's going to append it to the app service log within the var log directory. The var log directory within the container is mapped to the opt apps logs directory of the host. And when the container creates the logs within the var log, it is visible to the opt apps logs directory. I am not going to create the container at this time because it's going to create lots of logs. And when we are ready to start Fluentd, at that time, I will be starting our application container. Now it is time to connect all the dots together in our Fluentd configuration file. Let's start with the source directive. The source directive defines where to collect the logs from. We are going to use the tail plugin. The tail plugin will be tailing the log file, our application log file, which is mentioned within the path attribute. Fluentd will be using the pass underscore file attribute to keep track of the last file read in order to avoid duplicates. The tag attribute is used by Fluentd to route the log data accordingly in the Fluentd pipeline. And the format JSON is a parser plugin which will convert the log data into a JSON structure. So as part of the Fluentd pipeline processing, the filter directive is going to intercept the log data with the tag applog. It is going to apply the transformation. As part of the transformation, it is going to remove the field demo underscore field from the JSON structure. The match directive defines where to forward the application logs. The match directive is going to intercept the log data with the tag app log, and it's going to send it to the Elasticsearch. But before it happens, it has to be buffered. That's what our configuration says. And when the buffer size has reached its capacity, it's going to flush, and the flushed log data is going to get forwarded to the Elasticsearch using our output component. As a first step, let us start our application container, which is going to produce logs that will be consumed by the Fluentd. The application container is started. Now let us start Fluentd in debug mode using our configuration file. Looks like the Fluentd has started successfully. It's collecting the logs. It is forwarding to the Elasticsearch, and let us now go to the Kibana dashboard and let's see if you are able to see those logs. I am currently in the Kibana homepage. Now let's see how do we view the container logs within the Kibana dashboard. Go to the hamburger menu, click on the discover, and we should see all our logs here. Let's review one of the log entries. As part of the JSON structure, we passed three fields: the create date, message, and demo field. The create date and message, we are able to see it, but the demo field, as part of the transformation filtering, it has been removed. Awesome. So now we are able to demonstrate how the application logs were generated through the container, how Fluentd picked up those logs, collected those logs, forwarded those logs to the Elasticsearch, and finally through the Kibana dashboard, now we are able to view those logs. Now you know the basics of Fluentd, its architecture, how to install it, and how to use it. Have you tried using Fluentd with Elasticsearch and Kibana? What kind of challenges did you face? Drop in your thoughts in the comments below. Hit the subscribe button for more videos like this, and thank you so much for watching this video. Your time is valuable.